Okay. Now I'm like 5 minutes.
All right. So again, before we did some review for the exam, and then we were working on chapter 4, which was all about rational expressions and things like that. So we just kind of talked about what an irrational expression was and kind of what the graph looked like. Remember, it was the graph that had like the two pieces. And so this is about multiplying and dividing rational expressions. Now remember, rational expressions is just another way of saying the F-bomb, which is fractions. I know you guys were thinking of another word, but it's fractions actually. All right, so today multiplying and dividing rational expressions, this is pretty much the same kind of thing as, yeah, it's been weird today. As a matter of fact, my last class, it kept saying, hold on, we'll get you back in as soon as possible. So it was like it was kicking me out and then let me back in. So I don't know what was going on. Hopefully that has passed. And then soon after that, we didn't have any internet here. So yeah, it's been a little weird as far as that kind of stuff. So anyway, multiplying and dividing rational expressions is pretty much a fancy version of multiplying and dividing fractions. Just got some extra stuff. Yeah, I believe that. Jim was over here helping Mr. Morales today too. So I was pretty lucky in that respect. Like some of them, their classes were missing, all kinds of stuff. But I think it's because my classes are all year long. Some of their classes are only semesters, so I think the switch over, there were some problems. But, all right. So how you like the picture? Before COVID, this was my idea of fun. Going to an Iron Maiden show, you're like, who's Iron Maiden? They're popular in the States, but they're probably the biggest band in the world. Love these guys in South America. They play soccer stadiums for multiple nights. And like I said, they do okay in America. The last time they were through, they played over at Amalie. So, I mean, they're still pretty big here, but, you know, it's not like they're playing Raymond James or something like that. Yeah, probably not for a while. You love metal? Nice. You like the more extreme stuff? Or you like more of the traditional metal? Pantera, that's pretty old school. Did you ever hear their early albums where they were pretty much a hair band? That was pretty hilarious. It was still pretty good, though. Very cool. I saw the Cowboys from Hell tour, actually. They were opening for what was considered a hair metal band, but they were better than that. A hair metal band called Skid Row. And Pantera was the opening band. Oh, a little bit of weirdness, though. You're aware of what happened to their guitar player, Daryl Abbott, that he was literally shot on stage in Columbus, Ohio. Yeah, well, here's 18 in life. Yeah, that's him. Anyway, so the show that happened, like I said, was in Columbus, Ohio, at a place called the El Rosa Villa. I was supposed to go to that show, and my buddy's car broke down on the way to the show. Yeah. Ever been happy that a car broke down? Yep, that time. Yeah, totally blew my mind when I heard what happened. And the craziest part, the guy, and I don't know if you've ever seen, they actually have some security footage of this. If you see like the Pantera behind the music, if you look that up like on YouTube, was an old VH1 series they used to have. Anyway, they show the cop. He walks across the stage like the freaking Terminator, pulls out a I with this guy. Could not believe it. They announced his name, and I called a buddy of mine. I said, "Is that the Jim we know?" Because the thing about it was, it's not a common name. His last name was Niggemeyer. That's not a common name. And I called a buddy of mine. I said, "Is that the Jim we know? Is he a cop in Columbus?" He says, "Yep." I was like, "Oh my gosh." So I had all kinds of weird connections to Pantera. Yeah, a lot of people do. Like I said, unfortunately, the brothers are gone. I know Rex and Phil, they have their projects, but well, we could talk about metal all day. I've always said they should let me do a class on like hard rock and metal music. That would be fun because I could. But anyway, back to math. All right, so it says write an equivalent expression and express the domain. All right, so let's think back for a little bit. So domain is the possible values of x. And a lot of times they're defined as the values of that x cannot be. And that's the case here, because what we're looking for is we're looking for numbers that, when you plug them in, give you 0 on the bottom of this fraction. Because that's the whole thing with the rational expressions are fractions, and bottom of fractions can't be 0. Okay? All right, so if we look at the bottom of this thing, let's do that first. This is something Charlie's good at. So if we look at the bottom of this, we're going to go ahead and factor this. All right. So it's going to be x and x. So x times x is x squared. The minus sign here means we're going to multiply two numbers together and get a negative answer. That means one's got to be plus, one's got to be minus. Okay? And this is where Charlie's good. So we need two numbers that multiply together and give you minus 30 and add together and give you positive 1. So that means one's got to be positive, one's got to be negative, right? So what's our two numbers here? Uh-oh, Bailey beats Charlie to the punch. Now 2 and 15 would be too far apart, bud. Remember, the smaller the number is in the middle, the closer they got to be together. So we're going to go with the 6 and the minus 5. Oh, no, don't be sorry. We haven't done this for a while, but I know you're good at this. Okay? So then this would be x plus 6 and x minus 5. Okay, so the domain means when do either one of these parentheses go to 0? So that means in this case, x does not equal minus 6 and x does not equal positive 5. So x cannot be those two numbers. So that's your domain. Anything but negative 6 and positive 5. Okay? So then the next guy, first thing we can do is everybody's got an x here, right? So that means we can factor out an x. So we bring an x out front, and that's going to drop all the powers here, right? So instead of x to the third, we're going to have x to the second. Instead of x to the second, we're going to have 4. Okay. All right, so same deal here. So the top of this guy is going to have to be two numbers that multiply together and give you minus 12 and add together and give you positive 4. And again, one's going to be plus and one's going to be minus. So what's our two numbers for that guy? So we're going to have x. I'm trying to factor this guy, right? And the bottom's going to be x plus 6 and x times a minus 5. So we need two numbers that multiply together and give you negative 12 and add together and give you positive 4. So what's our numbers going to be here? So minus 6 and 2 would give us a negative 4. We need a positive 4. So it is 2 and 6, as you both figured out. So which one's going to have the plus? Yeah, so it'll be plus 6 and minus 2. So 6 times negative 2 gives you negative 12, and then 6 minus 2 gives you 4. So this will be plus 6 and minus 2. Okay? So now, pull into the cancellation station here. What can we get rid of here in this bottom one? What can we get rid of here? We need something that's on the top and the bottom that we can cancel out. So do we see anything that the top and the bottom has in common? The x plus 6? Yeah, I think that's it. So we can get rid of that guy, get rid of that guy. Good. So then the rest of it is your answer. That's all we've got left. So then you'd have, on top you'd have x times x minus 2. And on the bottom, you would have just x minus 5. Now, here's the thing. This particular answer, that's correct. If you plug a 6 in or a negative 6 in there, you won't get 0 on the bottom. But remember, in the original one, you would. So this still stands true. So even with our new one, even though minus 6 won't give you a 0 on the bottom, you still can't do it because in the original, you couldn't do it. Okay. So the domain is still everything except minus 6 and positive 5. And then your simplified expression is this guy right here. Okay. So they have a fancy name for this in calculus when they have something like this that was originally in the bottom and was causing a problem, but you get rid of it. People in calculus, I call that a removable discontinuity. Ooh, nice. All right. So basically it means originally you couldn't have that number, but we could cancel things and such that we could get rid of it. Yeah, they try to make themselves feel important. That used to happen to me a lot when I was up in Ohio. I was teaching online. But we had like times we'd have like open houses and stuff, and like, kids would come by with their parents and stuff like that. And I always seem I'd get that one dad that's like, well, I have an engineering degree. And I'm like, yeah, so do I. That always shut him down. Like, sorry, bro. Go try to be impressive someplace else. It doesn't work in here. All right, let's check out another one. Okay, so same kind of deal. Yeah, I did that stuff for a while, but I thought I liked working with high school kids better, so I do this now, even though I make a whole lot less money. It's a whole lot more fun. Okay, so let's work with this one. So again, we want to see if we can factor some stuff out. So on the top there, we have an x squared and an x. So remember we said if all the terms have an x in them, which these do, we can always factor out the smallest one. So we can factor out an x to the first or an x. So we'll factor him out first. And how about 3 and 15? Is there a number I can divide both 3 by and 15 by? Yeah, not a whole lot of choices here, but we can do 3, right? So then the top will be, we got 3x squared divided by 3x. That just leaves us an x. And then we've got 15x divided by 3x. As the x's cancel, 15 divided by 3 is plus 5. Cool. So that's the top. Okay. So the bottom, we can see if we can factor this guy. So notice that the bottom here, our number is negative 10, right? Now, we can factor this legit, but here's the thing. These are math problems in a math class. They want these to work out, right? They'd like to have something to cancel, right? We have an x plus 5 on the top, right? So I'm thinking probably one of these guys is going to be an x plus 5. Okay. So how do we figure out the other guy? That's easy. You take minus 10 and divide it by 5. What's that give us? What's negative 10 divided by 5? What's our answer on that? Yeah, actually negative 2, right? There's your guy. And like I say, if you factor that legit, you'll get x minus 2 and x plus 5. But we're going to use the fact to our advantage. So they want something to cancel out here. So we're going to use that fact to our advantage. At least this is what I used to do back in the day. Okay. So then that being said, state the domain. Well, the bottom tells us the two numbers that it can't be. So in the first set of parentheses, if you put in x equals 2, 2 minus 2 is 0. That's a problem. So x cannot be 2. And in the second set of parentheses, we've got x plus 5. If we make x equal to negative 5, then we have minus 5 plus 5 is 0. So x cannot be minus 5. So for our domain, everything works except x equals 2 and x equals negative 5. Those guys do not work. Okay, so as predicted now, we pull into the cancellation station. What can I cancel out of this expression here? What do I have on the top that's the same as on the bottom? Yeah, the x plus 5, right? Cancel that out, so then our simplified answer is going to be 3x over x minus 2. With the stipulation that x cannot equal 2 and x cannot equal negative 5. So as you can see, 2 is still a problem. Negative 5 in the new. Okay. Any questions? Yeah, and that's what I told you just there a little bit ago. It comes up on my screen. It says, hold on, something went wrong. We'll get you back in as soon as we can. So I just quit talking at that point. But yeah, that's what's going on today. And like I said, that happened in the other class. Fortunately, so far, it's not happening as often in this class. So it's all good. Yeah, you guys have mentioned that on a few occasions. I never worked with Blackboard, so I didn't know it. I worked with another platform up in Ohio. I don't even remember what it was called anymore, but it always worked pretty well. So let's go ahead and check out another one here. All right. So again, it looks like we're going to be factoring the top and pulling a common factor out of the bottom, right? So let's work with the bottom this time. So I've got y squared plus 3y. So they both have a y in it, so I'm going to bring a y out front. Okay. So now I've got y squared, so y squared divided by y is just y. And plus 3y divided by y is plus 3. And again, if you want to make sure that this works out, y isn't much better than the first one, but oh well. So if you multiply back together, y times y gives you y squared. Y times plus 3 gives you plus 3y. So there we go. Okay, so let's use this to our advantage. So we're thinking that we're going to be able to factor this guy into two pieces, right? And I'm thinking one piece is going to be y plus 3. What do you think? So to figure out the other side, we're going to take negative 24 and divide it by 3. What's that give us? Yeah, so it's going to be 8, but since it's minus 24, it'll be negative 8. All right, so we just got to watch our signs a little bit, but other than that, you're right on the money. And like I say, you could still factor that the normal way, and you'll still come up with x plus 3 and x minus 8, right? All right, so what can we cancel out then? Yeah, we can cancel out the y plus 3. One quick note, though. We should note that we have y cannot equal 0, right? And y cannot equal negative 3. So we have to make a point of that first. And then, as you both mentioned, we can get rid of the x plus 3, or actually the y plus 3. So then your final answer is just going to be y minus 8 over y. So that's your simplified expression. And here's your restrictions, as I sometimes call it. Okay. questions?
Sorry to cut like that, guys. I'll start again. But let's see. Hello, Mallory. We've been watching inauguration, obviously, and it wrapped up. But I still want you guys. There's still some value in watching coverage. And I'm just guessing. I could be wrong that you guys don't watch.
Yeah, some of them aren't too bad. We'll do a couple more and then we'll call it. So, Charlie, what's your dad play? What did he play in the band? Or was he a singer? He was a singer. That's cool. I've heard of them. They're from Tampa, right? Yeah, and if I remember right, because see, like I said, I worked in a CD shop in the '90s. They were popular in the '90s, and there was a lot of death metal coming out of Florida. And it seems to me those guys were like they had something to do, or some of the guys came from a band called Obituary, and I think somebody else was involved with Cannibal Corpse, if I remember right. Because like I said, we used to sell a lot of stuff, and it seemed like all the bands that were really into the death metal stuff were all coming out of Florida for some reason. That's cool. So they're still a band. Like I said, I wasn't really heavy into the death metal stuff. I know some of it, but you know, I was a little more of a traditional metal guy.
We will get back to where we were tomorrow. We have a lot of things.
Oh, bummer. That happened to another local band here. They weren't so much a death metal band. A band called Sabotage is from this area. Matter of fact, I see their bass player around St. Pete. I've seen him a couple times. Just kind of walking around St. Pete. But yeah, their one guitar player got killed in a car crash too. His friends are still part of it. That's way cool. Yeah, we were talking before about the guy from Pantera. I think Eddie Van Halen gave a guitar that he was buried with, and then he's buried in a Kiss coffin. The band Kiss.
Okay, ladies, any issue? Okay, Mallory's go. Oh, sure. Leave early.
All right, let's go over this one. This one looks ugly.
Okay, I'll see you tomorrow, Mallory. Hope you're doing fine. Thank you very much.
You love Pantera, you love Kiss.
Okay, be honest, just you and me. If you want to talk.
Both?
Hopefully, doesn't matter to me, but I was going to say to you, and you're probably wondering.
I've seen Kiss I don't know how many times. First time I saw them was in January 1976.
So, what I need from you are those transition notes.
First time I saw Van Halen was in 1978. They opened for Black Sabbath.
Okay? And I need you to answer them like really thoroughly so that we can talk about it at the meeting. You know, we don't hold you to it, right? Like you're not committed to what you're doing in the future. We just need to know now, okay? So do you have the notes still from the email? Can you check on that?
Double Platinum? Yeah, it was a compilation of like their first 3 records, I think.
All right. You guys are on it. Awesome.
Oh yeah, I'm old big time.
I really need those today, okay? So I can work on.
Let's just say I'm a lot closer to your grandmother's age there, Charlie. That's all right. The music keeps you young. All right, so this next one's ugly because it's got like A's and B's in it both. But we can still treat it the same way, and that's the whole point of this. Is even when they give you something that looks kind of scary, and they like to do that on purpose, by the way. you can still work and do the same stuff and then come up with the answers we're looking for.
Okay? So, and
awesome.
Email them back to me, okay? Because I really need them today. At least by like dinner time or before I go to bed. Okay? But hopefully a little sooner.
So is she your dad's mom or your mom's mom?
All right. Do that, and I hope to get your email, and I'll see you tomorrow.
Okay. No wonder she's into metal. Dad was into it too, right? Cool. All right, so let's look at this. Let's go ahead and factor the top. Nice. So on the top here, we've got an A in both of these, right? So I can drag an A out front. And we've got B to the third and a B on the other one, so we can drag a B out front, right? So what do we got left? If we've got A, B to the third, and we divide that by AB, then the A's cancel. I can cancel this B, and I can drop the power here to 2. So that means I've got B squared. And in the other one, you got minus 9AB, and we divide that by AB. So that's just going to be minus 9. Okay. We'll come back to that guy here in a minute. There's a little more we can do with that, but let's go ahead and work with the bottom. All right, so first thing you notice about the bottom is I've got 12, 12, and 144. That means I can factor out a 12, right? Okay. And then we have A in all of them, right? We got an A here, here, and here. That means we can bring out an A. Okay. So if we do all that, then we're going to have first one here, the 12 and the A cancel out, so you just have B squared. 12 and the A cancel out of the next one, you got plus B. And then the A cancels, and then we have negative 144 divided by 12 is minus 12. Okay. So we factored that stuff out, right? Cool. All right, so let's look at the top again. B squared minus 9, that's what they call the difference of two squares. And that will factor. So we say the square root of B squared is B. The square root of 9 is 3. And since it's negative 9, you're going to have 1 plus and 1 minus. All right, then here we have the 12a. Okay. Then we'll see if we can get this guy to factor. Okay. So this will be B and B. Minus 12 means one's going to be minus and one's going to be plus. Okay. So now we need two numbers that multiply together and give you negative 12. And then we have two numbers that multiply or add together, give you 1. And it has to be 1 plus and 1 minus. Okay. So what's our two number for this guy? Your mind's blanking. Well, remember this. When the number in the middle is small, so it's 1, that means they have to be just 1 unit apart, right? And you think about the numbers that multiply together and give you 12. 3 and 4 are 1 number apart, right? And since the overall thing is positive, yeah, so we use the 3 and the 4. 4 will go here, and the 3 will go there. Good, minus 3. So this will be b minus 3, and then plus 4. All right, so now we have to talk about the numbers that can't be. So a can't be 0. If a is 0, then the whole thing is 0 on the bottom, right? So a does not equal 0. And b, we have 2 possibilities there, right? So b cannot be 3, right? And b cannot be negative 4. All right, so we keep all that in mind. All right, what can we cancel? So the b minus 3, yeah, we can get rid of that. Anything else? Yeah, we can get rid of an a because we got an a on top and an a on the bottom, right? So then all we got left, we're going to have b, and then b plus 3 over, we got the 12 on the bottom, and then we got the b plus 4. And that's it. So there's your final expression, and then this part here is what it can't be. Any questions? Okay, so we'll practice some more of this stuff. Hey, the good news is tomorrow's Thursday. You only have 2 classes this week. All right. All right, I'm going to go ahead and shut down the recording. So, Charlie, I've been sitting here racking my brain because I hadn't thought about those kind of bands for a long time.